All right. Hi, Harshita. You had some questions, so I'm going to go over those. Sorry I couldn't get this out to you sooner. Yesterday was my birthday, and I actually got distracted because some of my friends put together a surprise, like Zoom video chat. Um, so hopefully this will still help you out before you take the test. So you had a question on problem 3. So problem 3 says you buy tickets to a baseball game. How many ways can 4 boys and 3 girls sit if the girls must be in the middle with 2 boys at each end? So for this problem, I'm trying to figure out the total number of ways that they can sit. So I'm going to use the method from day 3 called the slot method because that would give me the total amount of outcomes in the scenario. Each slot is going to represent a seat. So there should be 7 slots because there's 7 positions or seats that we're trying to fill. Sorry. Okay, then it says that the boys are going to be at the ends. So if you think about each slot as a seat, there's going to be 2 boys on one end and 2 boys on the other end for a total of 4 boys. And then the 3 girls will be in the middle. All right, then when I fill these slots, I'm putting the total amount of options I have for each seat. So if I start in the first position, seat 1, there are 4 boys right now that are not sitting yet, so I have 4 options for seat 1. Okay. When I move on to the next seat, a boy is now sitting in the first seat. So now instead of 4 total boys, I only have 3 boys left that can sit in that next seat. All right, now let's move on to the third position. The third position is a girl seat. So now I'm going to look at the fact that I have 3 total girls that aren't sitting yet. So I have 3 girls that can sit in this position. When I move on to the next girl position, one of the girls is now sitting. So there's only 2 girls left. And then once I move on to the last girl position, there's already 2 girls that have filled the first 2 seats, so now there's only 1 girl left. All right, the last 2 seats are our last boy seats. So remember that we had 4 total boys, but 2 of them are sitting in the first 2 seats. So now I have 2 more left for that 6th position. And then once I get to the 7th seat, all the boys are sitting, so there's only 1 boy left. All right, if I multiply each of those numbers, I'm going to end up getting the total amount of ways that all these 7 people can sit with 2 boys on the ends and 3 girls in the middle. So that total is 144. All right, so that's problem 3. You also had a question on problem 10E, which was the tree diagram. So if you look at part A, you can see my tree diagram. If I count the last column or last row, that's the total number of outcomes to the scenario. So there's 18 total outcomes. In letter E, we want what is the probability that you get chicken noodle soup or Caesar salad. Or means that you don't need to have both of them at the same time. Or means that you could either get a meal that has just the chicken noodle soup and then, other types of salads or sides. Or you could get a meal that has Caesar salad. So I'm going to focus on the first portion, which is the chicken noodle soup. That is this whole section here. I always want to count the last row to get the total number of outcomes. So if I count breadstick, roll, fruit, breadstick, roll, fruit, those are all of the possible meals that include chicken noodle soup. So that's 6 total meals that have chicken noodle soup in them. All right. The second number will be the Caesar salad number. So we've already included all of the chicken noodle soup options that have Caesar salad. But there are other soup options that have Caesar salad. So I could have a Caesar salad with veggie soup and a breadstick, veggie soup and a roll, veggie soup and a fruit, or with tomato soup and a fruit, a roll, and a breadstick. So that gives me 6 more outcomes that include meals with Caesar salad. If I add those two numbers, there's 12 total meals that would have either chicken noodle soup or Caesar salad. Because it's probability, you always want to put that over the total amount. So the total amount in this scenario is 18. So 12 out of 18 is 2/3. All right, the last question down here, I'm going to start over because I noticed when I was looking over it, when you had the question, that there was a little mistake. So maybe that's why you were kind of confused on it. The mistake that I had made was the innermost number. It was a really kind of stupid mistake that I made. So I'm glad you brought that up. The innermost number is always where I begin when I have a triple Venn diagram. So my Venn diagram is representing students at a high school who play basketball, gymnastics, and track. The teal number says those are the 5 students that play all 3 sports. So this little sliver here should be 5. Now, the mistake I made was I put a 3 there because I think I read all 3 sports. So I just put the number 3. Okay. Then I want to work my way out. So if I look at the next number that's kind of selective, that's that purple number that I highlighted. It says 12 students are in both gymnastics and basketball, but not track. So if I circle the basketball and gymnastics circle, the overlap between those circles is here, but that number 5 is also in the track one. So 12 should go up here because those are those students who are just in basketball and gymnastics, but not in the track circle. All right, next I'll move on to the blue number that I highlighted. That's 21 students who only play basketball. So that's going to be the students in this category. And then the 6 students who play, who do track and gymnastics, but not basketball, would be this number. It's kind of the same idea as how I filled in that number 12. All right, so those are all of my like selective numbers. So now I'm going to fill in the missing pieces by using the total amounts that I have. So I have a total amount of 45 students who play basketball. So what that means is that the basketball circle has to add up to 45. So I already have 3 numbers represented in there. This portion is unknown. So to get that portion, I'm going to take 45 minus 21 minus 12 minus 5. So I'm going to just subtract all of those numbers that I have from 45. I'm going to end up getting 7. All right, now I'm given the 37 students are in gymnastics. So the only portion of the gymnastics circle, I'll highlight that. So this is gymnastics circle. The only portion that's missing is this portion. So I'm going to take 37 and subtract the other numbers that are in that circle from 37, because the total number of students who are in gymnastics or in that circle should be 37. So 14 goes here. And then the total number of students in track is 26. So I already have 3 numbers in that circle. So I'm going to subtract those 3 from 26 to get how many students just do track. So that should be 8. Okay, so now I can answer letter B. How many students play both track and basketball? So that would be the overlap between the 2 circles, track and basketball. It doesn't say anything about whether or not they could be competing in gymnastics. So the overlap between track and basketball is the 7 and the 5. So that would be 12. Like if it had the word only, so if it said they play only track and basketball, then I shouldn't include the number 5. All right, and then the last one's probability. So probability means I need a fraction over the total. The way I get the total amount in a Venn diagram is I just add all the numbers in the circles. So don't try to add the the original numbers like 45, 37, and 26, because those numbers include some overlapping people, like people who play basketball and gymnastics, etc. Add the numbers in your circles. So if I add all those numbers up, I'm going to end up getting 73 total people who are competing. And there's 8 students who run only track out of 73 total. So that fraction should be 8 out of 73. All right, if you have any further questions, let me know. And good luck on the test and enjoy the beautiful weather this week.